to Thursday. I think tomorrow I'm just going to work class. So today I'm going to finish up the perimeter and area, and then tomorrow I'm going to give you some time to work on the assignment. I just assigned number 1 and 2 yesterday of assignment 2 because we had just talked about perimeter. So let's quickly just go through those. I don't think there's a huge issue, but let's just try it anyway. So perimeter is a measurement. We add up the outside edges of a shape. This is obviously a rectangle. It should be obvious. So that means this side is 7 centimeters and this side is 16 centimeters. So then the perimeter would be 2 7s, 2 16s, and that gives me 46 centimeters. Right? That's pretty easy. This is not a regular shape, but it looks like there's 2 rectangles put together. So the perimeter would be, well, I've got 4, 6, 3. I have a 3 here. So I have to figure out these 2 sides. So if this whole side is 4 and this little piece is 3, then this must be a 1. And if this whole length is 6 and this is 3, well, this must be 3. If they don't give you the measurements, you have to fill them in. So the perimeter will be 6 and 4 and 3 and 1 and 3 and 3. So we get, I think 20, right? 20 meters. Okay, so that's what the word perimeter means. You should remember the definition of perimeter and how to find it. The next thing was finding the circumference. Now the circumference is a fancy word. It's the perimeter of a circle. So the circumference has its own formula. It's 2 times pi, and pi is a number. It's a non-terminating decimal number. Between 3 and 4, closer to 3. Don't use the number 3.14. That's not complete pi. Pi goes on forever and ever. So there's always a symbol in a scientific calculator. Find your math symbol or your pi symbol on your calculator and use that one. Times the radius, right? And here the radius is 4.5. The radius is halfway across the circle from the center to a point on the circumference. So 2 pi times 4.5, I get a circumference of 28.27 feet. I do have to round, but I use my 2 decimals to round. Now here, they gave me the diameter, but the formula uses radius, or that's the version we're using. So the radius will be 15 inches. So 2 times pi times 15. We get 94.25 inches. Okay, and that's it. So the rest of the assignment talked about area, which we haven't done yet. So that's what we're going to start today. So we could see finding the perimeter, we're talking about not just a linear measurement, but we're talking about we have to measure, for here I had to measure in this direction, right? And then in this direction for area. Same with this piece. I had to measure in this direction and this direction. Anytime you have to measure in 2 directions, you're talking about area. So area develops enclosed shapes. And the definition of area is the measurement of the amount of space covered by a 2-dimensional object. 2 dimensions, directions. You could substitute the word direction in for there. Area is measured in units squared, okay? And the why we say squared is the name that represents units. This is in 2 directions, right? For example, the rectangle below has been filled with blocks that are 1 centimeter on each side. Okay, so this represents a centimeter, a centimeter, a centimeter, a centimeter, centimeter, 6 across and 4 down. Each little block is referred to as a square centimeter. I mean, literally the word square comes from the shape of the square, right? So each one of these is a square centimeter, a square with centimeter long sides. Since there are 24 of these boxes, we say that the rectangle has an area of 24 squares, right? 24 square centimeters. Each centimeter or each square is measured in centimeters. That's why we say it's 24 square centimeters. So instead of kind of drawing each shape in its grid form and then counting the squares, as long as we know the two dimensions, right? Another way to get these 24 squares is just to multiply 4 times 6 equals 24. So as long as we know the height and the width, or the length and the width, as long as we know the two dimensions. Now, if this was flat on the ground and this was a floor, I'd be measuring the width and the length of a room. If this was a wall and it was standing straight up, I'd be measuring the height and the width of the wall. So whatever the labels are matters, I guess, to the context, whether it's a floor or a wall or a desktop. But to actually find the numerical number, the area number in square units, it's just multiplying the two dimensions together, whatever the two dimensions are labeled. So the shortcut to arrive at this number is to use the formula for area of a rectangle, length times width. Keep in mind the actual labels might be different, and as I just said, base times height, but the concept is the same. The math is the same. So let's look at the formulas for areas of all the, now we're just going to focus on area of all the regular shapes, the common regular shapes. So we've got the formula of a rectangle. It's length times width, or dimension times dimension. Square, same thing, right? The two dimensions, it's just that the two dimensions are going to be, it's the same thing. Or if in a square, you could just, because the dimensions are identical, you could just use the square operation on your calculator, or the exponent 2, because these numbers will be the same for a square. Now for a triangle, this is interesting. It's the base, so the bottom of the triangle, times the height, however long the triangle is. Note for a right angle triangle, if I had a right angle triangle, one of these guys, one of the sides actually would be the height. But you have to find the height. The height has to be the line that forms a right angle triangle, or a right angle with the ground, with the base. Now you can also do this area version. You could just go base times height divided by 2, if that's easier in your calculator. Half, it's the same thing, right? A half of the base times height, or the base times height divided by 2. For some calculators, it's easy to type it in this form, base times height divided by 2. And then we have the circle. Notice this is the radius. So the area of a circle is pi r squared. I'm going to circle this version. This is usually the version I use, base times height divided by 2. These formulas will be provided always for you on a test or final exam. So you don't need to make up a special formula sheet. And it's in this year for sure you don't, right? So again, area is used to calculate things like paint to cover a wall, carpet to cover a floor, things like that. Determine the area of the triangle shown below. All right, so my area of a triangle formula is just base times height cut in half, right, divided by 2. So this is obviously the base. This is the height. Notice it's given to me at a nice perpendicular measurement to the base. So area equals 4.5 times 3 divide 2 and I get 6.75 centimeters. Very important. Area is always in units squared, right? This 2 means it was a shape measured in 2 dimensions. This means 2-dimensional, 1 dimension, 2 dimension. Determine the area of the circle. Now, circles are different. It's not as easy to see, but you are measuring in 2 dimensions, right? you are actually measuring the area of the circle this way and this way. Might not look like it, but you are. So area of a circle equals pi times r squared. Okay. This r means you measured the radius this way and this way. That's what the r squared means. Okay, so this is the radius. So great, I can use the 2. Pi times 2 squared. So in your calculator, that pi button is going to be very important. Pi times 2 squared equals 12.57 centimeters squared. So anytime you're using the area formulas, make sure you include your units. If it's linear, right? If it was a linear measurement, like the circumference of the circle, it would just be in centimeters. The radius is just measured in centimeters, but I measured actually two directions of the radius, and that's why it became centimeters squared. But area always is, you have to signal that it's in 2 dimensions. And the area of the square shown below, okay, well, area of any rectangular shape is just length times width, right? Or side times side. So I have 8 times 8, which will be 64 feet squared. And that's it. So really straightforward. The concept is a little trickier, but I think pretty straightforward. I'm going to stop now, and I'm going to get you to finish up assignment 2, and I'll go over the answers before you finish, or before we finish today. I'm just going to write a little note here. Finish assignment 2. I'll go over it before class ends. Okay. Okay, I'm gonna finish going over the examples for number 3. You probably did have enough time, it wasn't that involved. They just, now that we talked about the perimeter, now they want you to do some questions involving area. So you've got your 4 main formulas. There's actually only 3 main formulas because the rectangle and square are the same, just side times side. So there's only the side times side formula, the pi r squared formula, and then base times height divided by 2. Interestingly enough, it's base times height is the same as side by side. Like if you could envision this being a full rectangle, base times height divided by 2, because every triangle is just half of a rectangle. Even this one, it looks a little odd, but base times height, if I took 2 more of these triangles, like this, there's a large triangle split in 2. If I took these 2 pieces of the large triangle, created more, and then pieced them together properly, a full rectangle would form. So every triangle is just half of a rectangle. All right, let's talk about this area. It's going to be 4 times 10.25, and whatever that equals, I get 41, and I just have to make sure I put my units squared in. Now part B is a circle. This is the diameter. I don't want the diameter, I want the radius. So 8.5 divided by 2. The radius will be 4.25 centimeters. So area equals pi times 4.25 squared. And that gives me 56.75 centimeters squared as the area of the circle. Okay? So really just very minimal multiplication is required. So base times height divided by 2. And we get 6.4 inches squared. That's the area of that triangle. Moving on to part D. Well, this one's very easy. I don't think I need a calculator for 3 times 3. 9. Now remember, this is feet. That little dash uses feet, but I'm not going to use the dash. I'm going to write out the word feet squared. If I use the dash and then a 2, it would almost look like 9 exponent 12. So when you're doing units squared or units cubed, don't use the little dashes. It looks it's very confusing. All right, this is the radius, so I am going to use that. So I get pi times r squared. And I get 113 point, I guess it would be 0.10. And then finally, base times height divided by 2. I get 85.5 kilometers squared. Okay, and that's it. So that is it for assignment 2. Not that bad, right? The concept might have sounded challenging at the beginning, but really it ended up being not too bad. That's it for this lesson. Tomorrow, I think I will start on area of irregular shapes. It's still a familiar concept, area of irregular shapes. I'll start on that tomorrow, and we'll see how far we get into tomorrow's class.